Hello friends, I'm Rajesh from EIT Chennai. So let's discuss functions in Python. Basically, functions are used to create a set of group of related statements put together which can perform a specific operation. That can be followed up in all the languages like formal languages like C, C++, Java and all the other roots languages. Same way, here in Python also you can use a function. Normally we need to have a function name. The function has to have a name, and we need to do just some of the tasks to be executed under that name. And also we can call that function. We call it as a calling the function. Some of the functions need more than one or more pieces of input. So when they call, so others do not. So always some functions may return a value or sometimes may not return the value. So let's call that returning the value. Why do we need of this functions? Normally to reduce the code duplication, suppose we want to increase the program modularity, so automatically you will be preferring the functions. So once you are creating a software cannot be implemented by any one particular person, because in an industry and all, the people will be working as a team of programmers. Each set of programmers will be assigned with a specific task. They will be put up under a particular module. Likewise, we have a n number of different modules to develop a particular project. Assume that each module is having around 100 different sub-modules, thousands of sub-modules. Then you can prefer this set of functions. So there and all you can just you can easily implement this set of functions. And let's see that some of the terms they call it as KLOC. That is nothing but a line of code. Basically, the line of codes, number of line of codes, if it is thousands, normally that is been considered as some sort of application program. If it is going with a million line of codes, then it will be like normally will be the storage will be under the operating systems or smartphones, or if it is a gigabytes of codes, lines of code, then there will be a various programming languages. Normally we will be creating through as a code. So now we see that some of the other important points to understand the functions. In order to manage the complexity of a large problem, we will be breaking down the entire module into small subproblems. So by the way, the subproblems can be created as functions, and the program routines will be providing that opportunity for a code to reuse. The reusability is one of the main features, but reusing concepts and all, it's been very much highlighted in OOPS concepts. And even Python also is a OOPS language. Since it's a OOP language, you can go for reusing the code, and also so that you do not have any type of stuff from the scratch concept. Okay, let's see what is a function routine. We call it as either function or routine. Both are named as the same, but it's a group of instruction will be performing a specific task. That's what I told you in the beginning. And a routine can be invoked. The function can be invoked, or we call it as a called. It will be called as many times as you want, as need in a given program. The routine terminates automatically. The execution will be automatically at the point from which it is being called. This is how actually the things will be happening. Suppose I have a routine A, which has been written once, and whenever I need that particular routine to be called again and again, I'll just simply call back and will just return back to the same position, called position. So we'll see some of the next few slides are coming with how the subproblems are working. Suppose we have a bigger problem, suppose we were asked to find a solution to the major problem, it can be sometimes very difficult to solve. So what we do is that we try for breaking down that into a small subproblem. For example, if you are building a car, it's a major problem. No one knows how to make every single part of a car. So what we do is that simply we just identify the number of different people who are involving in the building a car, and we'll check their responsibility. Based on the responsibility, we'll give that subtask. That's got. So based on the subtask, we'll just give it to them, and finally we'll just take all the smaller manageable tasks and we'll make it as you'll integrate it. We'll finally produce as a one single entity called as car. So that's what we go for a step-by-step set of operations, and finally we just try to uh, make it with a one simple solution to the problem. So that's how we are just breaking the major problem. Always each stop can be again further we can breaking down into small sub problem, and we can go for a step-by-step operation instruction to be followed with a number of limited steps so that you can just solve that all the sub problems. Basically, we follow a top-row design. Top-row design uses the same method to break the breaking up a problem into a manageable steps. First of all, we should know how we are breaking up the problem into small problem to produce the top-down approach. So normally we follow up a top-down. Why we are saying that the top-down design is that at the top we have a very complex problem, one single complex problem that has been again divided into, say, for example, around 5 different sub-problems. The next level. And the third level, again, each sub-problem may be divided into another 20 steps, probably 5 into 3. So probably 15 to 20 steps, 20 sub-problems. So that way we can just refine the problem into several sub-problems while we go for a refining into the manageable steps. That's why the way we follow up. Suppose take the real project, for example, real-time problem. If I go for repairing a puncture in bike wheel, so let's start with a simple algorithm. Our problem given is that to repair a puncture on a bike wheel. So what are the steps I will generally follow is that my first step will be I should remove the tire, then I have to repair the puncture, and I have to replace the tire. So this is the general activity, it's a module I have to follow up. Now, again, I'm going for refining that first step. What is the first step is that my first problem is removing the tire. I cannot say that, I should not say that simply if I say that as a removing the tire, it's not that easy to remove it from that vehicle. I can also follow other different remaining refining that into a sub problem. What is my other different refining? That's what again I'm just going in deeper into that. What I do is that I'll just turn the bike up and down. I'll just take the lever off one side of the tire, then I'll remove the tube from the tire. That way I should use some sort of technique to remove the tire. And I'm trying to refining the second step too. My second step says that I should repair the puncture. Simply if I say like repair the puncture, it is not that easy. So just simply I have to find the position first and where the hole is on the tube, and then I have to clean around the area, then I have to apply the glue and patch. Then I have to just wait for some time, then I will just fill the air, I will just put up, I'll check that again if there are any other different areas which are all coming with any air or puncture, then I'll go for it. I'll just do this repeatedly, check it again and again. And once everything is done, I'll just go for it. I'll go for the third step. This is the third step. Again, the third step also has been refined now. I'm replacing the tire. So what I do is that I just simply if I say like replacing the tire, I'm supposed to push the tube back inside the tire. Then I have to just replace the tire back on the wheel, then blow up the tire, then I have to just turn up the bike in the correct way. So this is the actual refinement. So still, if you want, you can go for more number of refinement. That's what they're just highlighting here. Look at it. They're just trying to refine the second step. Again, just 2.1 is that it says that find the position on the hole. That's what I told you. I supposed to just from a loop, I dip into the water, I check it, I fill the air, I check it again, so till I get a hole, I just identify the positions, I keep following this as a looping. So normally when you're going for defining the functions in Python, we'll come back to this Python code. Basically we'll give it with that function definition. So normally the definition is one of the key point. So we use that def is the keyword to represent the functions in Python. So look at the example down. Always my function headers would be like that. You look at it, def followed by function name. My function name is here is that avg, and then I have listed of some of the arguments here. If you want to keep arguments, you can just list it out, or you can put an empty function brackets. Then at the end of it, you just put a colon. There, once you press enter, it will allow you some sort of indentation. There it comes with the function block. That's called the function body. So this is how you have to add up that functions in Python. However, now we see that how we are going to define the functions. We'll have a number of items under the parameters. Look at it. Either we call it as actual argument, or we call it as simply arguments, or formal argument. We'll see that what are the way we are just using it. Look at it. I have a three different variable called num1, num2, num3, all are assigned with some values 10, 25, 16. Here, look at it. This is called the calling of a function. Simply, I'm just using the function name with argument and pausing. So every function must be defined before it is called. So you have to just define that function with this sort of procedure. I supposed to just follow this sort of method. Then I have to call the function. You see, I told you that there are two ways to represent the parameters. One is that actual parameter, or we call it as simply arguments. Normally, this actual parameter is that simply the values which is being passed to a operator. That means that simply when you are calling the function, that place will pass this value. That time it will be acting as an actual parameter. And when you're defining it, when you're writing the function body, that time when you are representing the function header, there you will be placing with that. I think we'll come back to the this sort of n1, n2, n3 are called as the formal parameters. So it's formal parameters simply acting as a placeholders. So actual parameters are matched with the formal parameters at the end. The assignment role will be happening, and finally will be just matching with the original value. So see some of the assignment statements, how it has been working. Just a recap of it. If you're using the assignment like this, it is simply the spam will be assigned to this spam. That means that this variable will be holding this string. And likewise, if I go for 2 versus 2 pair assignment, this is called tuple assignment, position assignment. Always the first position element, the right side will be assigned to the left side. My m will be assigned to stan, and my m, uppercase m, are assigned to tab. So this is what, even you can go for list type of assignments, is as one of the another powerful assignments. Again, it's a positional one. First item will be paired up with first item on the left side, and the second item of the right side is assigned to a second on the left side. And same way you can also go for sequence assignments, generalized one. You can see here, if I give it as a string, and the left side I have an equal number of variables, each character in the string will be assigned to the particular variable. And if I use this star, look at the another assignment, a comma star b, means that since it is the right side I have a string, my first character will be assigned to the first variable, and I have used the star. It means that it's just like a extended sequence. It's like unpacking one. If I use star, what are the remaining strings characters or which are available, which is unassigned, that will be referred through this b. That means that a has been assigned to assigned with yes, and remaining pan is being assigned with b. Okay, this is called multiple tower assignment, another powerful way of assignment. Just like here we are discussing that again. I'm just telling you this is all just like how we are using the assignment operator. You can see here this string lunch is being assigned to two variables, spam and ham. And same way you can look at it. This is called that some sort of augmented assignment. We have simply we have assigned 42 to a spam. That means the 42 will be added up along with the spam plus 42 is the final value. And look at it, they're just, if you want you can execute it. These are all executable code. They are just assigning that tuple of items into that list. My right side I have a tuple, and my left side I have a list. So simply they're just making an assignment. It will be assigned automatically. And if I follow up this set of assignments, automatically 1 will be assigned to this, and 3 will be assigned to the second one. And same if you go for a string assignment to this pair of double items, I'll just take the first character into the first double item, second character into the second. Likewise, I will assign the character to a double, and same way you can look at it. So again, I have a sequence here. Simply, I'm just assigning the sequence into this 4 different variables in the left side. All the sequence item will be taken up. The first item will be assigned to the first variable. So likewise, just following up normal assignments, and you print it, it will come out with the value. But simply, if you're mismatching the number of variable, there will be a error. You will have some sort of too many values to unpack. Some sort of value error will be coming. See to that when you're giving a sequence, you are following up whatever the number of items which has been given in say the sequence should be equal to the number of variable on the left side. So that's what we followed. If it is mismatched, there will be an error. That's what it's been highlighted here. And another one is that there is some sort of reference unpacking references there. As I said earlier, if you go with this only two variable, probably if you put up with the star reference, automatically what are the remaining items will be. What is a star? I think if you go back to that and check it here, it's called an extended sequence. So whichever the remaining item will be just like will be assigned to the this star followed by that variable. Only that corresponding sequence you can see here, only A is being assigned with the first character, the remaining characteristics is being assigned to B. Same way they are trying it here in this sequence, so automatically 1 will be assigned to A, and for B the remaining item 2, 3, 4 will be assigned. Likewise, if you are exchanging that extended packing here, instead of B I'm just extending to A. That means that B is being assigned with the last item, the remaining rest of all items is being assigned to A. That's what is happening here. And now they are playing with the three values, three variables. My first and last items in the sequence is been specifically assigned. The remaining all the rest of the item is been assigned to B. That's what is happening. Look at it. They're printing the A comes with the first item, and B is coming with the remaining item. I C is coming with the last item. Okay. And same way they're just making up another different examples. They're having a string as usual. If you print with A star B, A is been assigned to yes, and remaining all will be assigned to B. And if you go with the three variables, first and last will be assigned to that. That means S and M will be assigned to A and C, and B will be holding that PA. That's what is happening. And even if you go for ranging, my range 0, my first range and last range will be assigned to the specific variables A and C. Remaining all the stuff, all that remaining values, range values are assigned to B. That's what is happening. Okay, now come to that functions example. Okay, now to begin with, I create a function. That's what as I said earlier, the functions would begin with this keyword def space, the function name. I created a function name, can be any customized name, just like any user defined name. I'm creating with the function name here, and my argument is here, and then I'm just inside my function. Look at it, I have a colon symbol. If I press enter, this will give a room for entering the function block statements, function body. There I have given only one statement. Simply I'm just printing a hello followed by a message. That means whatever the message which you are passing while calling, along with that message, there will be a string called hello. Hello will be printed at the first beginning, and then followed by plus symbols, appending symbol. Followed by that we'll have a message. Same way they create another function like a mathematical function that consists of my function name is that adder, and that consists of three arguments. First argument doesn't have any value, second argument is initialized with some value, and third argument is a pointer, some sort of reference, and then I created this function body. There I have written it with this, simply I'm just adding up all the three elements. So Even the function can be created with return type or without return type. It is possible in Python. Look at this. There is another different functions here showing up. Simply they are having a function name as times, which follows two arguments, and it returns that multiplication of those two arguments. So when Python runs this particular function, this def automatically creates a new function object that packages the function code and assign the code to assigns the object to the name times. Same way for all other functions will be followed. And when you call the time function, times of 2 comma 4, automatically that just check for the matching function name. This is my matching function name. My x and y's are 2 and 4. So automatically that returns the 2 star 4. That is my result. That will be 8. Same way if I go for look at the second one, 3.14 followed by 4. Now what I do is that my x is 3.14 star 4. 4 is my y. So automatically saves the result in the floating point. Even if you want to go for passing the other different arguments, like see here one string with the look at the last call, one string with one number, one integer. So that is the beauty, like irrespective of any type of arguments, it accepts. Look at it. First call comes with both are integer. Second call comes with my first argument is floating point, second argument is integer. But if I go for the look at the third one, first argument is a string and second one is integer. For all it works. That is the beauty of it. And look at the another example. I have a function called intersect that has been created with a two argument, and my function body, inside my function body, what I have done is that I have created an empty list. My list name is res. Then I create a loop. My loop starts with counter x in that sec1. Sec1 is the my first argument, and I just find out inside that loop. I just find out if x in sec2. That's just like I'm just checking with my second argument. That means assume that both are collections. Okay, collection 1, collection 2, sequence 1, sequence 2. Under the sequence 1, I'm checking it, is there any item which is matching with the sequence 2. Just like I'm checking for the matching common item, and that has been added at the end. That's what it's been created as a empty list at the beginning, that now it's been added. If it is matching, that common item is being added up. So this function specifically is been created where when you are going for intersection, when you're going for finding the common item between two collections, two lists, two different dictionary, or two different tuple, or some sort of collections. If you are going for finding out a common item, there and all you can use this sort of logic. Okay, and this is another example. I have a yeah, I think the same example. Sorry, I have a two different collection. Like S1 is a string, S2 is also string, and why not? You can pass the string as a collection. It's also possible. And I'm just calling the function. Look at the third statement in the set of S1 comma S2. So now it has been called, and I'll just check through this. It will go to that function. It will just execute this. It will run a loop and check for the common item. Automatically check for the first versus first. S1 first item is that yes, and my S2's first, second, third item will be matched. Automatically first item is matching. So item 1 is yes is a common item, and check for the second item. My S1's second item is that my second character is P. That will be checking against with all the S2 item. Yes, C, A, M. No matching. It won't be appended. And it'll check for the third item in the S1, sequence 1. A. A will be checked with against with the scan. SCAM. A is the again A is matching the third item in the second sequence. So that will be appended. And that last one in the sequence 1 is that M. M will be checked against with the SCAM. According to this loop I'm just talking. So finally it will just print with the common item as SAM. Now we go for discussing about that comprehension. almost you can here what they're highlighting is that instead of comprehension, you can also use that function. That's what that they're saying. This is a equal comprehension. Look at the first few snippets that comes with the comprehension. They're creating a comprehension. They're creating x. They're using a for with a counter x in sequence 1, and then they're adding up a condition if x in S2. It will be simply printing that common item. So even this set of comprehension can be altered with the function. That's what it's been put up in the second half. Look at it. I have called a function called intersect followed by I'm passing the sequence 1 is this, sequence 2 is this. So finally I'll get this common items. So it's even you can mix up the types, it's possible. So always the def statement, when you're creating a function object and assign to a name, always def is a true executable statement. When it runs, it creates a new function object and assign to a name. Because it's a statement, always it can be appear in anywhere. You can create this def function anywhere, even nested to other statement is also possible. So wherever you create a def, look at it. This is another typical example. It's one of the interesting example. I have a condition called if. If condition I'm using it. If test. Then inside my condition I'm just using a def keyword. I'm just using the function name as fun. Then I'm using a else spot. Then also I'm using the def keyword with the fun. Fun is my function name. So what to do is that always fun is the normally look at it. I just down. I'm just simply calling this function. What it does is that it check for the corresponding call which is matching with this function name. This, but it is typical case here. I have given it under this condition. Since it has been given it under the condition, check for the corresponding test condition. It define this function either the true block way or in the else spot way. So it will call the versions selected and build it. So look at it, how they are using this function definition in the selection statements. They initialize that A as 4, then they have started that condition A modulo 2. That means that they're checking that whether that is moduloing with 2. If it is modeling with 2, which returns that this is a 0, then they have created a def. That means they create a function. That function prints the even. Otherwise, that another function they have created, that function prints the I. But see here, they're calling only once. Remember, look at that. They have only the same function, only one function. The same function is been again been defined the else block also. This sort of activity, this sort of concept is possible in Python. Functions especially, you can redefine the function if at all, if it comes with a selection statement, some sort of conditions, you can do for it. See here, I have called this function. So what I do is that simply just check for this condition. Once this condition is matching, as of now my A value is 4. So automatically this condition satisfies and this will be executing the true block. If I change that A as 3, then it will go to the else spot that brings the add. So look at it, this one. But simply I'm just calling that only one function and I define that same one function multiple times in my if else condition, so it works. So look at it, there is an error here. That's why they're highlighting. I think the same program is being modified. If I give it like print 1, there won't be any predefined function called print 1. So it will be showing up error. So remember that we should give only that print So print 1 must be defined. So automatically it just, if it is working on normal way, it will work as the p1. And uh, again, in this case, it's supposed to execute the else part, but since my else part function definition is header is correct, but inside my function body, I have given as print one. So again, there is a error. Instead, if I give it only print, it will work normal. So not a problem. So now see how we can call through a variable. The function can be called through a variable. It is possible. Look at it. That's what another interesting part here in this example. I have a function called 1, 2, 3. My function 1 is printing simply 1, and similarly my function 2 is printing 2, and my function 3 is printing 3. And look at it. I'm just putting up a multiple elif later conditions. So I am trying to just look at this inside my all my conditions. I'm just assigning this variable name variable into the some sort of, let's say I have a call underscore fun. Let's see that. I have created here as 1, 2, 3 as a function, but that same function name which has been assigned, but here I have used that as a variable that has been assigned to another. Left side I have another variable. Remember, these are all acting like a variable, but at the end of this elif later, look at it, the last one, I simply call the function. My calling function is call underscore fun. So automatically what to do is that it consider the matching assignment. So automatically I have assigned it 1, 2, 3 are functions. So now it will be matching that particular function will be assigned to that variable left side. So automatically my as per this logic I have a as 3, but if my a equal to 1, then that will print that will just do this first operation, or 2 it will perform this second operation. But my since my a is 3, that will call the last else part. So what I have done is that in the last else part I have assigned that 3 into the call fun. So automatically that will just execute this 3, that will print the 3. That's what the output. Okay, so hope you understand this. Now we'll see some of the other important part is that when you're creating a variable, you should understand what is the scope of the variable in Python. When you're going with the enclosing module, automatically that scope is, we call it as a global scope. So automatically when it's going with the enclosing module, that is called as global scope. And the global scope spans a single file only, that has been only with a single file, and always all the assigned names are local unless and until if you declare it as a global or non-local. Each call to a function will create a new local scope. So this was the actual name rule. We call it as a name resolution. We have LEGP rule. L is that local. We come from the innermost local, let's call that inner functions, followed by enclosing. E is for enclosing function locals, and then G is for global, let's call that module, and B is the built-in one. So we follow this LEGP rule. Based on the scope, we see some of the example. I have initialized variable which has been initialized outside of all this block. We call it as a global scope. My variable is capital X equal to 99. And look at that next few statements. I have a def, that means that my function fun, which have argument y. Inside my block, I have a z equal to x plus y. Now y and z are obviously a local variables. What about x? But since I have initialized that x outside that function, it has been acting as a global. So the global will be having a higher preference. So always it will be overtaken. So rather than this local. So automatically it will be considered that global. When I call this func, automatically it will be returning x plus y value. So automatically my x value is 99 and y value, it's been passed here, my func 1. So 99 plus 100 is the result. So we have normally we have a global names for x and func, and my local names for innermost local variable x and y and z. Now we go with another example. Similar way like the previous example, I have created a global variable called x, which has been assigned to 88. Then inside my function func, I have reassigned the same x variable with another value 99. That is a new value. So once you are calling this func, what it does that if you are printing that x value, automatically the local value will be hiding the global. So when you're printing it outside, that prints that global. When you're printing it in the local, that prints the local value. So automatically local x will be hiding the global. That is a rule because since it is due to that LEGB rule, it follows up. And we are asking a global variable. Look at another different example. I have a x, it has been initialized to 88. That is in the beginning. It's called global section. Under this local, I have a function. I have a but I have again, if you look at it, I have mentioned as global of x. That means I'm retaining the same visibility here, and then I'm just reassigning that x into other different value. Then I'm calling the function. I'm printing that value. What it does that when it is going, when you are printing it outside, automatically it prints that only that the whatever ESM. Since we have given here as a global, this will be acting as a global. Whatever that inside this block we have assigned it, that will be acting as a global value. Even though we have already initialized in the beginning, inside my local scope, I have given as global. So that will be my final one. That's the reason why it's printing with 99. And also you'll see how we are accessing the global variables. We have y and z just been assigned to 1 and 2, and we have a function called all underscore global, and there inside that function and inside my local scope I have I'm making a x as global. Then under that I'm just adding up y and z. Finally it will just print all those values. 1 plus 2 is 3. So no need to declare that y and z as global, because since I already declared inside my function x as global, automatically it will be assigned to a global variable. So no need to declare that y and z due to that LAGB rule. So global variables and global scope always is generally will be considered as a pair programming style. Avoid using the global variable and global scope. So better that if you are a formal programmer, good programmer, always try to use only the local scope type of local variables. Why? Because there won't be any protection on the variable values which it holds. So there is a problem. And now we go into that nested of how we are going for nested functions. So look at the example here. I have initialized the global variable x with 99. Then I created a function f1 that it has been created with the function block. Inside that I have re-initialized the same variable x with 88. Then I have created another function f2. There I am just printing that x. And again inside that same f1 scope, local scope itself, I'm just calling that f2 Then I coming out and calling the F1. Once I call this F2, what it do is that it just check for the corresponding function which has been available. Yes, it's there. It'll print that local. Once it goes with the F1, there also it'll just print the F1 that local value, because automatically the enclosing will be having the highest priority. Enclosing def local. And you will see here some of the function which comes with the return here. This is another example. I have function f1 which has been created with the function block statement. My first statement says that my x has been initialized to 88. Then I am just creating another function called f2. There I'm just simply printing that x value. Then I'm returning that f2. Now what it does that it returns that f2 but don't call. Why? Because we are not calling that function. Remember here the return statement is different here. We are just simply giving the function name. Simply it is just returning, it won't be calling. So that is a thing that will be happening. Don't misunderstand that as if I give a function name, immediately will be just remembering that it's only a function call. It's not so. Just simply return that F2. That's all. Look at the next statement. I'm just giving a function call here f1 that is been assigned to this variable. Now this will just make a return function, and when you're going for this way, this is called the function call. So this is just simply call the function that will return that. If I give like look at it, I just calling with, I'm not calling with the actual function name. See here, I'm just calling with the assigned variable name. That's what the clever thing, like, is one of the beautiful thing. It's like quite interesting one. We are just calling with the aliasing, not with the exact name. So if I call like action, even though my function name is f1, now it is valid. So it will be calling this function. It means that it calls the function, it just print the 88. So now always when you are going for returning a value to a function, always you should remember that similar to the mathematical function, it just only returns the value. When you go for function average, which takes some sort of 3 arguments, something like n1, n2, n3, automatically that returns the average of 3 values. Or when you're going with the average of, see here, instead of n1, n2, n3, I'm just passing these 3 arguments, it will find the average that return the result. So this is indicated that function will return the return statement of the, it will be like either expression or it can be normal value, returning a specific value or variable, that is possible. Okay. Now we go with another example. Look at it, how they are just calling the function with a value. I have a function called average, avg, which have 3 argument, n1, n2, n3. Then I'm giving a return statement for that function. There I have given us n1 plus n2 plus n3 divided by 3.0. Simply that finds the average. And while calling, look at the function call here down, the last statement. So I'm just using the function name, I'm passing the value, but I'm just following up other different operations. Yes, it's allowed. Along with that, I can do anything. What it do is that it just find the average and give the result. My result is 17.0. 17.0 star the factor that will give the result. This is the way that will be working. So always when you are calling, that will give the result as 17.0, and then along with it I'm doing another further operation, like I'm making a factor that will be given as a final result. Clear? So even the function can be created with a non-value returning. That's why we call it as a non-value returning function. So how do we call this as a non-value return function is that non-value return function is called not for a return value but for the side effects. What if a side effect is that? Side effect is an action other than the returning a function which is displaying on the screen. Look at the example here. I have a function called display welcome. There I am just printing all these statements. Okay, and when I call this function, look at this. So in this example, what I do is that simply just display that function will display the all this message. Only the side effect will be printed. So simply that without returning, simply that side effect will be printing. Just like it will print all these values. And in Python, there is another wonderful feature is that you can return more than one values. That is possible. That's called that returning a multiple values in Python function is possible. So look at the example. That gives you the idea. Like they have a function called multiple that consists of two arguments. And if you want, you can write the statement at the end of this function, return x comma y. Yes, it's allowed. This set of multiple returning is allowed in Python. You can try it and look at it. They're just taking up some of the example. They're counting the same function. X has been assigned as 1 and L variable has been assigned as a collection 1 comma 2 list collection. Now they are just calling this function multiple of x comma L is been assigned to x comma L. So that is possible. That means that my result value will be, suppose if I have a 2 and 3, 4 has been, I have assumed that I have written the statement as x is 2 and y has been assigned as 3 and 4. So both will be returned. My x is assigned to this 2, my L will be assigned to 3 and 4. Or if I call for this, simply if I initialize this value, 1 will be assigned to x and 1 comma 2 will be assigned to L. Even that way also will work. So now we'll see how we can attack some of sort of problems. So given the 3 points, suppose we're going for writing a Python program for it, I want to form some sort of triangle. So this is called the triangle formation problem. I have 3 points. Based on that, I have to form a triangle. But provided there is a condition that all these 3 points should not fall on a straight line, and length of the one side of the triangle should be less than the sum of the length of the other remaining sides of the triangle. This is the actual given problem. For this, let's see how we are going to solve it. We'll see that with the example before getting into that solution. Say for example, I have 3 points like 5, 10, 20, 10 and 15, 15. These are the 3 different coordinate points values for the triangle. And see to that all these 3 points are do not fall in a straight line, as well as the sum of one side is any of the sides should be less than the sum of the that is length of the any side should be less than the sum of the other sides. That should be the rule. This is a pseudocode for it. First we have to read the 3 points. Then we have to put up a condition. If the 3 points fall on a straight line, then we have to print that as a no triangle. Otherwise, just find the length of all the 3 sides and take the length. If the length of one side is greater than the sum of the length of the other side, then print that as a triangle. Otherwise, just print it as no triangle. This is the actual pseudocode, the step of operation. And straight away, the coding part has been given. Simply, we just put up, we read x and y coordinate value for all the 3 points, and we just put up a if else multiple LF ladder kind of a structure. What is the first if condition says is that I'm just checking all that point 1, point 2, point 3, all this different 3x coordinate value of all the 3 points. If all the 3 points x coordinate values are equal, then return true. Same way, I'm just checking for the y, all that point 1 y coordinate, point 2 y coordinate, point 3 y coordinate, all are equal. If I'm checking it, if it is equal, then I'm returning true. Otherwise, I'm returning false. This is one logic. Then I have to go for finding the distance between the 2 points. How will I go for finding the distance between the 2 points? That's called the length of a side. Simply, I just in mathematics we have a just like a formula, square root of x1 minus x2 whole square minus y1 minus y2 whole square, right? So that formula we are just following up with this sort of expression, and then we are returning the distance. So this is another subproblem, and then we are just putting up the another condition to check the length constraints. As far as the length is concerned, like once you find out all the length L1, L2, L3, all the three sides, then we check whether that first side length 1 is less than the other two sides, sum of other two sides. Or check with the second side in the triangle and check against with the other two sides. That sum should be less than that. Likewise, we check all these three sides. So now we got the point. Let's look at the program. We have just implemented this. Simply, we have read the 2 points through this x and y, and then we have created a just like a collection. We put up as point 1. Same way we are taking up another one, point 2. Then we are taking up another one as point 3. Then we are setting up some set of functions to check whether all these 3 points are fall on a straight line. For that we have created a function. Then we have another function for calculating the length distance. So for that we have created another function. We put up as a whole, we put up as a if if later, and this is what the actual function which is doing the operation of finding that whether the points, all the points are falling on a straight line. As I said earlier, I have already clearly given you this example uh, how to solve out this. Simply I'm just taking up all the points. Suppose I'm taking up all the x points, x coordinates of each point and y coordinate of each points. I'm taking up. If all are equal, I'll just return it true, otherwise I'll return it false. So that way it will work. But if I just run this, call this function now through this condition we are calling. So if all are true, automatically that will be printed as no triangle. Then when you are calling the second, another function called calculating the calc distance, that what we are doing is that we are just taking up that formula. As I said earlier, square root of x1 minus x2 square whole square plus y1 minus y2 whole square. So that formula they have followed up. They just finding all the distance of each side, length 1, length 2, length 3. I just mentioned, no, same thing they are following up. They are returning that all these three values at the end. So that will be returned here, and so if it is lesser, then that will be printing as no triangle. If it is length is not lesser, then that will represent the triangle. So almost we are coming to the end, and finally we are just checking that with this condition. So if it is greater, it will be returning true. So that's a probably similar way you can try for all this different set of problem exercise for you. Just try this. You can also go for computing a circle using all possible function prototypes, and also you can go for computing the simple interest problem calculation based on this, all this given attributes like principal, number of years, and rate of interest PNR by 100. Am I right? So that problem also can be solved through this. So almost